So the keyword is application. When we do engineering, it's basically the application of science, of the things that we're learning, the science and engineering principles to minimize the effect of human activity. And when we say effect of human activity, anthropogenic effect, basically we are talking about mostly in what term? What is this effect? This is pollution, all right? So mainly we are talking about pollution because human activity are the ones actually, damaging the environment in most cases, all right? If you just mention the natural cycle, it will just continuously go on. But because of the urbanization, the rapid population growth, right now we're almost nearly 8 billion people. And so there are a lot of, population density, and a lot of materials are being used and being disposed. And so the problem is these waste are actually going to our natural environment. And so instead of totally eliminating this one, which we cannot really do, environmental engineers or engineers in general are actually doing to minimize this effect of the pollution to the environment. So to the whole environment, this includes the natural environment as well as the people, the social environment, all right? So when we talk environmental engineering, as I mentioned earlier, is a combination of different fields, the works of the environmental engineer. So we talk about work in water, we talk about work in air, and we work in soil and even waste management. So there are a lot of things, and even life cycle assessment, all right, and sustainability. So this is the goal is to minimize the effect of human activity has upon to the environment. And this human activity is related to pollution. And this pollution can be divided into water, air, noise, and soil waste pollution. And you can see from here, we have a lot of pollution in sewage, for example. So especially in developing countries, most of the wastewater, or many of the, or majority of the wastewater are actually not treated. So what do? So if they have a plant, they have an industry, they usually just, discharge the water to the rivers, to the sea. So what happens now? So if you discharge without treatment, what happens is that you are accumulating a lot of nutrients there. Not only bacteria. Bacteria can also be a very big problem, but the nutrients, the nitrogen, the phosphorus will, enable the growth of many organisms, many plants as well, algal bloom. So it means that if you have algal bloom, which is eutrophication, what happens? Oxygen cannot diffuse anymore to the water. So if oxygen is not diffused to the water anymore, and the plants, the algae, are actually consuming oxygen, what happens? You have a water system underneath that is lacking of oxygen. So that means that your animals, the plants underneath, will lack oxygen. And so there will be a problem in terms of especially the fish, okay? There will be a problem of dying fishes. So this is one form of relation of the environmental engineering to pollution. So air pollution as another key factor. As you have in Sydney, just recently we have bushfires, right? So the bushfires, generating a lot of particulates. So there are a lot of advices from the government what to do with if staying at home or not staying at home, wearing some masks. So these things can affect our health as well. So if you are staying at home, the air quality could be more dangerous inside the home if you are closing your doors and windows compared to the air quality at outside. So as environmental engineers, we're able to assess this one, and we are able to provide some form of treatment process. And this is part of your task to treatment design process. All right, so what are the environmental issues that we are facing now? A lot of environmental issues. So these are just examples. One of the main causes of this one is population growth and urbanization. Okay, the population now in the world are actually now in urban areas rather than in the rural areas. So people are going to the urban cities to gain jobs, to have a better life. So now it's densely populated in the urban areas, and it's increasingly having a lot of problem with pollution. You can see from this example here, plastics are everywhere. So we have a lot of problem with plastics already. Plastic pollution in the sea, you can see like this. It also affects the fish and the seawater creatures. Not only that, what is the recent ones in plastic pollution is microplastics. Okay, so we have microplastics. We have recently understood that, okay, microplastics has been going on in wastewater now. So in wastewater treatment plants, sometimes microplastics cannot be treated well because of some limitations of the treatment process, like the membranes, for example. So microplastics is quite small. So in water treatment, at least we know the exact sources of this one, so we can devise a treatment process for that to eliminate microplastics. But sometimes now, microplastics can be transported via air. So there are a lot of studies now, or a number of studies, not a lot, but it's increasing number of studies showing that microplastics are actually transported via our atmosphere. So there's a study that saw that in Antarctica, there's a lot of microplastics deposits there already because of just transportation from air. And so in fact, this is a big problem because we are inhaling microplastics. In our houses, for example, we have some sofas, we have different furniture, for example. They're actually releasing fibers, small plastics. They're made synthetic ones that are actually going out in the air, and we can inhale them. So there's studies that showing the effect of this microplastic to our health. Some are debunking this kind of study, but we don't know exactly the long-term effect. But what I'm saying is that there are so many issues now, environmental issues, that we environmental engineers can actually try to help solving them. Beijing is an example. In China, there's a lot of pollution, air pollution. This is just an example. I hope this time is better, but just an example of the haze that is formed by the pollution in the air. So we can use some filtration system. For example, the mask is a filtration system. What we are doing in COVID now, the mask is a filter. So it depends on the kind of mask, and it depends on the filtration system that you can have a size exclusion effect or different types of mechanism on how it is filtering out. All right. So there are so many things. Climate change is another thing. As you can see, the global temperature is increasing year by year, as you can see from here, right? So our target is to limit the temperature increase by 1.5 to 2 degrees Celsius. Beyond that is unmanageable. We cannot imagine the effect on our life because there will be some devastating effect on the ice, and the ice will melt, and it will increase the seawater level, and will cause a lot of flooding as well. So that's one effect of climate change. And of course, you can see from here, carbon dioxide emission is a big problem, which is related to climate change. So we have a lot of factories that are emitting carbon dioxide. And our CO2 level, the ppm level in the atmosphere is increasing year after year. So we have new technologies now. For example, carbon capture and storage. So instead of releasing the carbon, we can make a device that can capture the carbon instead of releasing to air, and then we can store that carbon underneath the ground. All right, so that means we're not actually putting the carbon towards the atmosphere, which is very dangerous. We're trying to store the carbon. So there are new technologies that can work on that one as well. Okay, so these are example. Water scarcity is a problem with many countries in the world, especially in Africa. So we have water stressed regions, we have physical water scarcity, we have economic water scarcity. So depending if you have available water physically, or you have available water, but you don't have the infrastructure to get that fresh water, that's economic scarcity, water scarcity. Physical water scarcity is that one that you don't have the water available for the population, all right? So physically you don't have that, or you have physically the amount of water is there, but you don't have enough water to actually, the demand is higher compared to the source. So that's physical water scarcity. And then waste control, all right? A lot of waste in landfills, all right? So we have a big problem with this one. And this is a very big issue that environmental engineers can help out in devising some treatment processes. So what do environmental engineers do? We try to assess and develop technologies or develop processes. Assessment is an important aspect. We just don't develop right away. We need to assess and understand the problem, the impact of this, the problem, including the life cycle analysis. We need to understand how it goes from the source towards the end of that process, all right? That is where environmental engineers can work. So an example of this potential environmental impact is seawater brine. All right, you know that we have a desalination plant in Sydney, right? We have many desalination plants in Australia. And the desalination plant in Sydney just restarted this year, or no, late last year. We restarted late last year due to the drought, due to the dam level that we have goes below 50%. So we need to provide additional source of water. So now desalination plant in Sydney is working. But most desalination plants, what do they do? When you desalinate water, if this is seawater here, you use a membrane like reverse osmosis, and then you push that water inside the membrane, right? So this membrane is a semi-permeable membrane, all right? It means that it will only allow water to pass through, but not allow the salts to pass. So it means that the salts remain on the other side. The water goes inside, and then what is remaining here? Salts. So it means there's brine. So brine is a mixture of salt and water, but a lot of salts. So the brine solution is quite high right now. So this brine solution, usually they are discharged directly to the ocean. So if you discharge the solution with very high concentration of salt, what happens? What happens to the ocean location? It means that you are disturbing the water quality of that specific location. So if you have a lot of salts you put in the ocean as disposal, this specific location of this area, the pH changes, the temperature changes. The reason is this process here, if you press the pressure, the temperature changes, it increases as well. At the same time, the pH, because of the concentration of the salts, the pH changes, it's very high. So now, if you put water in the ocean, the pH and temperature changes in that specific location changes the solution as well. So what happens? If you change pH and if you change temperature, the sea life underneath will be affected because they are sensitive to these kind of things. If you change the pH, the same temperature, the sensitivity of the fish will also be affected. All right, so that's why. Okay, so this is one important aspect. So we need to assess what is that effect of that brine solution. This is an example. And then we need to develop solutions to environmental problems. So now we have example is removal of nutrients from toilet to tap technology. So we now have technology to convert, toilet water or wastewater into drinking water. It's happening in other parts of the world. All right, we can do it as direct potable reuse. It means that we don't put the treated water in a reservoir for a long time anymore. It's direct. You can just easily drink it, which is safe. Okay. But you can also have an indirect potable reuse, which is that you treat the water, the wastewater, treat it, put in a reservoir, make some kind of time, and then go the treatment process again for a water treatment process, and then you can drink the water, which is mostly the case in direct potable reuse. But we engineers, environmental engineers, civil engineers can work on these processes, and we have the technology now. Removal of nutrients or resource recovery, not only removal of nutrients, but reusing the nutrients. So we have a technology in our group, not me in particular working on this one, but some of our group members and colleagues are reusing the urine. So we in UTS, in building 11, we have a urinal there. For example, we have a urinal system that combines the urine into a storage tank. So what we are doing now are using membranes. We call is based on forward osmosis, based on membrane distillation process. We made some technology so that we can recover the nutrients, the nitrogen and phosphorus from urine. We are converting urine into a reusable fertilizer. All right. So that's one big thing, innovation for environmental engineers to do. So we can do that one as well. Also, aside from the process optimization, environmental do things in wastewater treatment plants, for example, in some other areas that need technical assessment. So we have a lot of things for work as environmental engineers or civil and environmental engineers. As I mentioned, this is another example, desalination and wastewater treatment. We can help in the design of the plants, what sort of processes. So we need to know the water quality of that specific source. If we are getting groundwater source, then we need to understand what is the quality of that source. They are less turbid, less bacteria, less So it means that they don't need coagulation much because it's less turbid. All right. So we know the specific process for filtration or for treatment process. So we are trying to make the most economical way of treating and the most feasible way to treat a water source or a wastewater source. All right. How to operate the plant is part of the environmental engineers' work as well. So we can work on this one, the process optimization using some software, modeling. We can all do this as engineers. Now, all of this is related to what we are having a new revolution now. We do things now. There are three main revolutions that we have. The agricultural revolution is main on the aspect of knowing agriculture and trying to expand agriculture, and so population grow. So there's a many years back. And then we have industrial revolution. The industrial revolution is the, there's a steam engine now, there's the use of some diesel, some gasoline. And so the industrial revolution has actually really made the manufacturing grow so much. And so that's why we have a lot of problem with CO2 emissions now. Now we are starting the sustainability revolution. It means that our goal now is more on sustainability. We are trying to optimize the process. We are trying to make the waste as minimal waste as possible. And we are trying to reuse everything, recycle. This is where we are now. As environmental engineers, we need to think about that, or as engineers, we need to think about sustainability. And so the United Nations have formed the Sustainable Development Goals. There are 17 of them. And of course, many of these are related to the work of engineers. We can work on clean water and sanitation. We can work on clean energy. We can work on sustainable cities and communities, and even the life in water and on land. So there's a lot of things that we can actually contribute as engineers to attaining the Sustainable Development Goals. All right. So you need, please try to be familiar with many of these goals. And there's a group, the National Academies of Sciences, Engineering, and Medicine is a consortium of different academics and scientists and researchers. They form, based on that Sustainable Development Goals by United Nations, they made 5 grand challenges to be addressed by environmental engineers. 5 grand challenges. So these are the challenged one. The first one is sustainably supply food, water, and energy. Second is curb climate change and adapt to its impacts. Design a future without pollution and create efficient, healthy, resilient cities, and foster informed decisions and actions. All right, so we'll try to have a brief explanation for each one. So we can see from here, there's actually a nexus. The first two is actually interrelated with each other. We have climate, energy, we have food, and we have water nexus. So whatever you do with other one, the other part will affect the other one. For example, in water, the climate change affects the water production, right? Or the water sources. So because of climate change, there's a lot of drought situations now. The lands are getting dry. You have a lot of problems with climate. The seasons are different. So we have a lot of flooding. So water is affected. And so if we are affected with water, for example, in hydroelectric plants, so if we have a dam and water is not there, what happens? So hydroelectric plants cannot produce electricity. So electricity you have a potential there. You need a volume of water so that you can produce electricity, right? So for hydroelectric plants, it affects energy as well, energy production. When you say energy production in power plants, like thermal power plants, you need water for cooling water purposes. If you have heat exchangers, you need to cool that water so that you recycle. So if you don't have water, you cannot you cannot cool the heat exchanger, all right? And you cannot produce energy. So this is very related. Of course, food here is related. So you need water to generate or to produce food. You need food to produce energy. We eat food as well. So food is a source of energy. So these are all interrelated with each other. So that's why environmental engineers are important for this aspect to contribute. So the first challenge is sustainable supply of food, water, and energy. We have a lot of population now, and nearly 800 million are not nourished, so they lack food. They don't have enough safe water, more than 844 million are not having water. More than 2 billion without sanitation. So it means they are just, you know, reusing of dirty water, and even their own toilets, they don't have that good sanitation. And 1 in 7 without electricity. So we can have that contribution of putting some new technology, or maybe optimizing some processes of these, you know, current technologies that we have. All right. So population, growing population in middle class. We have, in terms of the food, what we can do to minimize the impact of this to food security. We can utilize some sensor technology, for example, like in this example here. We can put some sensors on the how much amount of water is needed for each plant, for example. So you don't need to always water your little plants. You have some sensor technology here. You can monitor how much is needed. If it's needed water, then you can just put the water, or automatically putting the water. So it means that you are actually optimizing. You are not making some waste. Innovations in farming and aquaculture. So for example, this one, you can put it inland, right? So you can have these different plants here for aquaculture or vermiculture. You can have different kinds of culturing inside buildings, all right? So you can have that for food as well. And then we can reduce food waste by some protective films, like covering of the food. So we can reduce the waste, or consumer education. It means that, you know, changing the lifestyle. You can change your diet if you are not eating that much meat anymore. For example, this is an example. It means that you're also helping out reducing the amount of water being used, because meat, there are a lot of what we call as invisible or virtual water. It means that with one meat, it means it comes from beef or from cow, and the cow needs water in growing, you know, in nurturing. So you need a lot of water as well. So there are some virtual water needed. So if you change your consumer or your diet, you are helping out in that the changing the effect on water and food as well. Some sensors can be put on plants, some graphene-based sensors, for example. So this sensor will give automatic transmission to a digital computer, for example, and, you know, show you if it's needed watering or not. So it's or waterless toilets, for example. So there are many things that we can consider as a way of making things more efficient and less waste. Sustainable energy is another, switching to low carbon energy sources like wind power. I think I will be giving you some examples in our energy balance class about sustainable energy. We can also work on solar energy, you know, a lot of solar panels now, to instead of using some fossil fuel powered plants, all right? So because they emit a lot of CO2. And so we need to have more sustainable sources of energy, which in this case, wind and sun are very, you know, sustainable in the future. Climate change, as I mentioned, I think I mentioned this graph already about the curbing the change of temperature that we have, the increase in temperature below 2 degrees Celsius or 1.5 degrees Celsius as much as possible. Otherwise, beyond this one will be catastrophic events will happen, like flooding, a lot of changes in wind, in storms like that. And this will have a big impact on overall life that we have. All right. And then we can switch to electric cars, for example, or hydrogen energy. One of the main, directions of Australia now is towards hydrogen energy. So there's a lot of research now about hydrogen energy, converting all our cars now into more hydrogen powered cars, or electric powered cars, or a combination of both, because hydrogen, you know, contain a lot of energy that can be used for such purposes, and we can also doesn't release any CO2 emissions. So that's why it's going to be a clean energy for the future. Design grand challenge to design a future without pollution or waste. So in this case, we can see that in previous years, our model is more of a take, make, waste. It's a linear model. It means that we extract the resource, we produce and consume the resource, and then we just throw, right? Whatever it is. And there's a lot of waste going on without throwing. So this is just a linear way of model before. But right now, our way is more of a circular economy. All right, circular economy. So in this circular economy, there's a life cycle assessment. So we try to reduce as much waste as we can. We try to reuse or recycle as much resource as we can. All right. So we're reusing now, as I made this example for you. We're reusing the urine to make into fertilizer. That's a very innovative example now. And we do about green chemistry and engineering as well. So it means that instead of using some very harmful chemicals, we use some green solvents, for example, that will not have that much effect on the health. So we're using all of these things towards a more sustainable future. And then we need to eliminate the concept of waste. The concept of waste, as much as possible, waste could be a resource. Okay, so as I mentioned, a circular economy, a sustainability revolution should be based on this circular economy. And we try to reduce as much waste as we can and recover as much resource as